Hey everybody, so in this video, we're going to go over some other measures or calculations that are important when we're looking at data. So we've already talked about how we calculate the mean, the median, the mode, and the range, and why those four measures of central tendency are important and how we utilize them a lot when we're looking at sets of numbers or sets of data. But today we're going to talk about some things called quartiles, as well as a specific kind of data graph that you will see kind of on future assessments on the STAR test. And it actually is really cool because it kind of shows our mean, median, mode, and range, as well as some of these other calculations we're going to learn about in this video in a visual way. So sometimes I know for a lot of us, visuals make understanding math, and particularly when we have data, when we just have like lists and lists of numbers, a lot easier to understand. So the first part of this video is reviewing or talking about these 6 definitions that are going to come up. Some of you may get these definitions in class, so you might already have them written on the page. If you don't have them written on the page, what I'm going to do is I'm going to actually post them here for you to see. And just kind of briefly review them as not to take up too much time in the video, okay? So you can, if you don't have these written down, you can kind of write these down as I briefly review them. So the first definition, which is one that most of us already know, is the definition of what's called the median. So the median of a data set is the value that splits the data into 2 halves. So if we're looking at a set of numbers, and especially when we order them from like least to greatest or greatest to least, the median is the number that splits the data directly into 2 halves. And we have numbers that are smaller than the median and numbers that are bigger than the median. We also can refer to this as what's called the second quartile. Second quartile is kind of a lot to write, so we abbreviate it with Q2 because you can think about it as it splits the data into 2 sets. There's like going to be what's called the lower and the upper set. So that's what the median is. The 2 sets, or you could think about it, the 2 halves that the median splits all of our numbers into are called the upper and the lower half. So the lower half is the set of all of the values that are smaller than the median. So for example, if I let's say 6 is my median, and let's say I have the numbers 4 and 5 beneath it, this would be the lower half. These are the numbers that are smaller than the median. The upper half is all the numbers that are bigger than the median. So let's say if 6 is my median, I have the number 8 and the number 9. This would be the upper half of the data set. It's all the numbers that are bigger than the median. So we have our lower half, all the numbers that are smaller, upper half, all the numbers that are bigger than the median. If we look at these upper and lower halves, now in this particular example, they're pretty small, right? Because I don't have that many numbers in our data set. But if I had like a bunch of numbers listed, okay, if I found the medians of just this half, just the lower half, and just the upper half, what we're doing there is we're finding what are called the first and third quartiles. So again, first quartile, third quartile, that's 2 words, kind of a lot to write. Quartile is kind of a weird word to say. So we can abbreviate them with Q1 and Q3. So the first quartile is when we find the median of the lower half. So if I looked at these numbers 4 and 5, and if I found the median of just this lower half, that's called the first quartile. It's, you could think about it as this is like the first quarter if I split my data into 4 parts. Then there's something called the third quartile, or Q3. That's if I took the median of the upper half of the data. So if I looked at 8, 9, I found the median of all the numbers kind of on this side of the median, that values that are bigger. That's called the third quartile, because we're finding essentially the median of like if we split our data into 4 sections, and this is like the third section we're looking at. The actual quartiles, first, second, third, will make a little bit more sense when we put this information into what's called a box plot. We're going to kind of split a box into 4 sections. But that's essentially when I ask you, I want you to calculate the Q1, or I want you to calculate the first quartile, or I want you to calculate the third quartile. Basically what you're doing is you're finding the medians of the upper and the lower half. So it's kind of like you're finding the median of the entire data set, then you're going to find the median of like the smaller numbers and the median of the bigger numbers. So we're just calculating a lot of medians. in this kind of situation. Then the last definition that's important is something that's called the interquartile range. Now that is a super long word, and so we abbreviate it a lot of times with IQR, so that way we don't have to write out interquartile range a bunch. And so the interquartile range, this is showing us what's called the mid spread of the data, meaning where do the majority of our numbers fall. So for example, not with this example, but let's say like I had a bunch of y'all's grades from like quizzes or tests or something. The IQR, the interquartile range, is showing like where do the majority of students kind of range with the grades, because somebody may have gotten like a 20 and someone may have gotten a 100, but the majority of y'all, maybe y'all got between like a 70 and an 80 or a 70 and a 90. And that smaller range is what's called the interquartile range. So the way that we calculate it is we simply take the third quartile and the first quartile and we find the difference between the two numbers. We find the difference between the median of the upper and the lower half. And so I know that's a lot of kind of information. It's all going to come into play in the next, on the next page, because we're actually going to do some of these calculations. So this is just what all of these words mean. If you need to pause the video so that way you can get the definitions copied down, you can get the definitions copied down. But now let's go into actually finding or solving, calculating, whatever you want to call quartiles. So we're going to do two examples. We're going to do a data set that has an even amount of numbers and a data set that has an odd amount of numbers. So if you want, up at the top, you can put like example 1 and you can put even, because there's an even amount of numbers in the data set. There's 1, 2, 3, 4, 5, 6, 7, 8 numbers in this data set. And then example 2, there's an odd number. There's 1, 2, 3, 4, 5 numbers in the data set. So what we're going to do is we're going to practice finding those quartiles. So you would think it would be easiest just to go in order. Let's find the first quartile, then the second quartile, then the third quartile. But remember, we need to find the median of the data sets in order to figure out what even is our like upper half, sorry, this page, our upper half and lower half, right? Because we need the upper half and lower half to find the medians of these other values for the other quartiles. So the first thing we're going to do in both is we're going to find the median, and they are already listed in order from least to greatest in both sets, but if they weren't, we would want to go forth and list them in order. So if I look, let's do the first one. I have 8 numbers in this data set, so the median is actually going to kind of fall in between 72 and 73. So if I want to find the median or the second quartile, since I have 2 numbers that it falls between, I need to find the average of these 2 numbers. So I could do 72 plus 73 and divide by 2 to find the average. Or another way to think about it is I'm trying to find out what's exactly halfway in between these 2 numbers. Either way you kind of think about it, or if you solve it this way, you should get that the second quartile is 72.5. That is our median. And now we want to kind of use this median to determine what the upper half and the lower half of the data is. So the upper half is everything that is bigger than our median, everything that is bigger than 72.5. So I'm going to kind of like circle the group that's the upper half. So even though I had to use 73 to calculate my median, it's technically bigger than 72.5. So everything from like 73 on up, that right there, that is our, what's called our upper half. I'm just gonna put UH right beneath it, upper half. Let me zoom in so you guys can see it a little better. Okay, that is our upper half, which means, I'll change colors, that everything below 72.5 is what's considered our lower half. So from 72 and below, that is considered our lower half. So we used all of the data points in the set because our median is not actually a number in the data set, which is fine. So we took all the numbers that are bigger and all the numbers that are smaller. And now that we've done that, we can find our first and our third quartiles. So it doesn't matter which one you do, we can go in any order. I'm just gonna go find the first quartile. So in my lower half, I have 64, 68, 70, 72. So if I want to find the median of this lower half, since I have these 4 numbers, I know my median is going to be what's halfway in between 68 and 70. So there's a couple different ways we could do it. We could think about what's halfway in between, or we could do 68 plus 70 and divide by 2. We could find the average. Either way, you get that the first quartile is 69. If we do the third quartile, we're going to do the same process, but now we're going to use all the numbers in our upper half. So in our upper half, we have the numbers 73, 74, 77, and 83. And so what we're going to do is we need to find the median of these values. So the median is going to be what's halfway in between 74 and 77. So I can either add them and then divide by 2 to find the average, or kind of think about on a number line what's halfway in between. And you should get 75.5. So we have our 3 quartiles. We have our median, 72.5. We have our first quartile, 69, and we have our third quartile of 75.5. And when we, if we were to find what's called the interquartile range, we would find the difference between these 2 numbers. So the difference between 75.5 and 69. That's showing us kind of where the range falls. What's the kind of the actual range between the higher and the lower number, not the range of the entire data set, but like where most of the numbers fall. So we're going to do another example because I know that was kind of a lot to process. However, this time there's going to be less numbers in the data set, and there's actually going to be an odd number of numbers in the data set. So what we're going to do is let's find our median first. We're going to find our Q2 or our median. So if I'm looking here, since there's an odd number, this number that's right here in the middle, because they're already ordered from least to greatest, 9 is going to be my median. I don't have to find the average of 2 numbers in the middle, because when we have an odd number of numbers in the data set, it's always just right in the middle. So to find the first quartile, I have to define what's in the lower half of the data set. So I want everything that is less than 9. So everything that's less than 9 is going to be these 2 numbers, 0 and 6. So that's my lower half. Everything that is bigger than 9 is my upper half. So that's 15 and 19. And you'll notice when we have an odd number of numbers in our data set, we don't actually include the median as part of the upper or the lower half, because we have to pick numbers that are bigger and we have to pick numbers that are smaller. And so 9 is equal to 9, right? So like 9 can't fit in this group because it's not greater than 9. 9 can't fit into the lower half because it's also not less than 9, it's just equal to 9. So when we find the median of these upper and lower halves, we're not including the median. So I'll make a note of that at the bottom, that when there's an odd number in the data set, we don't include the median. So if we're finding the first quartile, we have to find the median of 0 and 6. So we could do 0 plus 6, or think about what's halfway in between 0 and 6. And the answer is going to be 3. And then if we want to find the median of the upper half, if we want to find the third quartile, we have to find the median of 15 and 19. So halfway in between 15 and 19, or the average of these 2 is going to be 17. So we have our third quartile 17, our first quartile is 3, and our second quartile, or our median, is 9. And so this is kind of where I just want to make a note. Do not include median, and you can put if odd amount. And when I mean odd amount of numbers in the data set. So you do not have to include the median if there's an odd amount in the data set. In the next video, I'm going to show you how we take these quartiles and put them into what's called a box plot. Feel free to go back and review these steps if you need any assistance.